Hello everyone, this is Heading Tian. In this video, we will learn chapter 11.8, expected value. First part, we will learn the compute expected value. Expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. Expected value is used to determine premiums on insurance policy, weigh the risks versus the benefits of alternatives in business ventures, and indicates to player of any game of chance what will happen if the game is played repeatedly. The standard way to find the expected value to multiply each possible outcome by its probability and add these products together. So we must find each possible outcomes and the probability. We multiply these two together and add them together. That's the way to find the expected value. We use the letter E to represent expected value. In the example 1, find the expected value for the outcome of roll of fire die. The sample space of rolling a fire die is equal sign here. 1, 2, 3, 4, 5, 6. So these are all the outcomes, each with the probability of 1/6. So by the definition of expected value, then multiply each possible outcome by its probability and then add this product. So normally I will create a table. The left column, I will put all the possible outcome here, outcome. And the right column is the probability. So what's the outcomes? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So these are all the possible outcomes. Each of them, the probability is 1/6, 1/6, 1/6, 1/6. The expected value used the definition is the outcome times its probability, and we add these product together. So first outcome is 1 times 1/6 plus second outcome times 1/6 plus third outcome times 1/6 plus 4 times its probability plus 5 times its probability. And the result is 21/6. It's equal 3.5. So the expected value of rolling fire dice is 3.5. Oh, DICE. That's my problem. Okay, let's continue to see example 2. Find the expected value for the number of girls for a family with 3 children. A family with 3 children can have 0, 1, 2, or 3 girls. There are 8 ways these outcomes can occur. So here, wait. So here is the 8 ways. For no girls, the 3 children in the family should be all boys. So this is one way. 1 girl, you will see we have three ways if the family have only one girl. The first is a girl, or the second child is a girl, or the last child is a girl. For the two girls, we also have three ways: the girl, girl, boy, a girl, boy, girl, a boy, girl, girl. And for the three girls, three children are all girls. We have only one way. So totally, the sample space number is 8. So let's draw the outcome and the probability table. So here is my outcome. Here is the probability. Outcome of having no girl, 0 girl, is 1/8 because we only have one way over the sample space number is 8. If the family have one girl, so the probability is 3/8 because we have three ways. If the family has two girls, that is 3/8 because three ways. And three girls. These three children are all girls. It's 1/8. So the expected value is 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. So the number should be, what is, this is 0, 8 is 3 plus 6 is 9, 9 plus 3 is 12. Is 1.5. So is the expected value of having a girl is expected value of the number of girls for a family with 3 children have is 1.3. Next one is use expected value to solve the applied problem. In example 3, an automobile insurance company has determined the probability for various claim amounts for driver ages 16 through 21 shown in the table. So the first question is calculate the expected value and describe what this means in practical term. That means we need to find the expected value. Since it already listed for us, we just use the outcome times its probability and add all the product together. Next one is 2000 times 0.15 plus 4000 times 0.08 plus 6000 times 0.05 plus 8000 times 0.01 plus 10,000 times 0.01. So the result is about 1100. So remember, this is the claim cost. So the unit should be dollar. Oh, yes. $1,100. So the expected value is $1,100. This means that in the long run, the average cost of a claim is $1,100. The insurance company should expect to pay $1,100 per car insured to people in the 16 to 21 age group. The second question, how much should the company charge as an average premium, so it does not lose or gain money on its claim cost. For this question, at the very least, the amount that the company should charge as an average premium for each person in the 16 to 21 age group is $1,100. In this way, it will not lose or gain money on its claims costs. It's quite probable that the company will charge more, moving from break even to profit. Next part. Okay, business decisions are interpreted in terms of dollars and cents. In this situation, expected value is calculated by multiplying the gain or lose for each possible outcome by its probability. The sum of these products is the expected value. The next example, example 4, you are a realtor considering listing a $500,000 house. So pause the video and read the video. I will explain it later. In this video, the question is asking you the expected value the realtor can make if the realtor sell the house, and compare the expected value with 6,000. If more than 6,000, the realtor will list the house on the market. If less than 6,000, the realtor won't list the house. Let's see how to find the expected value. So you will spend $5,000 if you list the house online or on the market. You need to pay for the food or the website or maintain the house. So remember, this is your cost. So this is the negative. That means you must pay for you must pay if you sell the house or list the house. What's the possible income? If I'm that realtor, if I sell the house by myself, I can get $30,000. If another agent sell the house, I still can make $15,000. After 4 months, I get nothing if I didn't sell the house. The probability here, if I sell the house, probability is 0.3. Another agent sell the house is 0.2. The house unsold after 4 months is 0.5. Let's see the outcome and probability table. If I sell the house, I can get how much money? You know that here, if I sell the house, I can get $30,000, but I still need to pay $5,000 for listing the house. So the money I can earn is 30,000 minus 5,000. So I can gain 25,000. Another agent sell the house. I need to use 15,000 minus 5,000. I can get $10,000 here. If the house doesn't sell, that means I will lose $5,000. So these are all the outcomes. I put the probability for each outcomes here and multiply the outcome and probability and add the products together. Here is the expected value. And I get $7,000. It's more than $6,000. so the realtor will list the house on the market. So this question is tricky part is whether you sell the house or another agent sell the house, or you didn't sell the house, you still need to pay $5,000. So remember, even the income I get by selling the house by myself or another agent, I still need to deduct $5,000 for listing the house. Or if I didn't sell the house, the house unsold after 4 months, I still need to pay this $5,000. Okay, let's move on to the next part. Use expected value to determine the average payoff or lose in the game of chance. Example 5. A game is played using one dice. Sorry. If the dice is rolled and shows 1, 2, 3, the player wins nothing. If the dice shows 4 or 5, the player wins $3. If the dice shows 6, the player wins $9. If there is a charge of $1 to play the game, what is the game's expected value? What's the meaning of this? So here is the table. If the outcome is 1, 2, or 3, I lose $1 because I pay $1 to play the game. This is -1. If the result is 4 or 5, I can gain $3, but still need to -1 because I paid the money for playing the game. So I can gain $2. If the outcome is 6, I can get $9 and -$1, which is 8. So list the probability here. So the sample space is 1, 2, 3, 4, 5, 6. So will occur 1, 2, or 3 is 3/6. If it shows 4 or 5 is 2/6. If it shows 6 is probability is 1/6. So the expected value equals -1 times 3/6 is 1/2. Plus 2 times 2/6 is 1/3. Plus 8 times 1/6. So let's see what's the result of this. It's about 0.5. Okay, so this means in the long run, the player can expect to win an average of $1.5 for each game played. Let's move on to next example. Actually, unlike the game in the example 5, the games in gambling casinos are set up so that the players will lose in the long run. In example 6, one way to bet in roulette to place $1 on a single number. If the ball lands on that number, you are awarded 35 and gets to keep $1 that you pay to play the game. If the ball lands on any one of the other 37 slots, you are awarded nothing, and the $1 that you bet is collected. Find the expected value of for playing roulette if you bet $1 on number 20. Describe what this means. So it's looking for the expected value. I will draw a table to show the outcomes and the probabilities. actually we have only two outcomes. One is you win, one is you lose. So if I win, I will win $35. And remember that $1 will pay it back to you. So I actually will win $35. And another outcome is I will lose $1 for each time I play. The probability of winning a game is 1 over 38 because if I choose a number which is 20, if the ball landed on 20, I will get the money. The probability of the ball will landing on the number I chose is 1 over 38 because totally we have 38 slots. The probability of losing $1 or I lose the game is 33 out of 38. It's landing on the slots except the number I selected. So the expected value is 35 times 1 over 38 plus negative 1 times 37 over 38 equals bottom is 38 and top is 35 minus 37 is negative 2, which is negative 1 over 19. And this probably equals, use your calculator to find negative $sign 0.5. It's about 5 cents. So that means in the long run, each time you will lose 5 cents in the game. So here is the table. The example shows us. So each time I will lose 5 cents. How about 2,000 times if I play the game for 2,000 times? So you use 2,000 times each time the money you can lose. That means if I play 2,000 times, 2,000 times negative 0.05, that's about negative $100. You will lose. Next example 7. It is estimated that there are 37 deaths for every 10 million people who use airplane. So what's the meaning of this first sentence? That means 37 deaths for every 10 million people who use airplane. What's the probability of the people deaths? I use D for death. The probability for death of the airplane is 37 over 10 million. Continue to read the question. A company that sells flight insurance provides $100,000 in case of death in a plane crash. A policy can be purchased for $1. Calculate the expected value and thereby determine how much the insurance company can make over long run for each policy that is sales. So we must find the outcomes and the probability. The outcome the first outcome is there's no death. So the company will get or will earn $1 for the policy. Another outcome is the death in the plane crash. The company will lose this amount of money, and also remember the people already paid $1 to buy the policy. So the total amount of company lose should be $100,000. And remember, they still get or gain $1 for the people who buying the policy. So the money he lose, the money the company will lose for the death in the plane crash is this amount. So find the probability for each outcome. For the death in the airplane crash is, we mentioned about in the first sentence, that is P of D, which is 37 over 10 million. And the probability of not having the death in the plane crash is 1 minus P of D. So it's shown here. The expected value equals $1 times the probability of no death in the plane crash, plus the negative 99,999 times the probability of death in the airplane crash. Is probably equals $0.63. So the expected value is about $0.63. So one person buy the policy, the company will get $0.63 for each person in the long run. Okay, this video is all about chapter 11.8. If you have any question, please let me know. Okay, have a good one.